So as part of digging into Agentic, let's talk about new protocols. In this episode of AI Insights with John Roese, I think it's important for us to spend some time kind of reminding ourselves that when you build an agentic system, it is not built with just tools that existed 10 years ago. There are actually new protocols being developed that are giving us capabilities that are necessary to make agents, a new thing, work. Two of those protocols that are probably the most important are, one is called agent to agent, and the other is called Model Context Protocol, or MCP. These two protocols are very important. They are not the same thing. They might become something similar over time, but the problem we have is that they're both very necessary and they're both very good ideas and they're compatible with each other, but we as an industry do a great job of confusing people about them. But yet, if you're a practitioner trying to put this stuff into production, you very quickly discover that you probably need both, and navigating them is non-trivial. So let me take a few minutes to kind of talk about these two protocols, give you my positioning of them, and then talk about where this might go longer term. So let's start with agent agent. Agent agent was built as an interworking protocol. It's designed to think of it as a way for you to connect two software systems, i.e. agents, to each other over a tunnel that's secure and trusted. And what primarily is happening within that tunnel initially is they're handing tasks back and forth. I have one agent that does certain things and I have another agent that does other things. And it turns out they work better if they actually can exchange tasks. That if this agent that, I don't know, needs a quote can send a task requirement to an agent that can get a quote, and then it can send an answer back, that's a good way to kind of make that process work. And the fact that agent agent is designed to work across domains means that the thing asking for the quote might be the customer and the thing giving the quote might actually be a vendor. They might not be in the same security domain. They might not effectively be part of the same system. They're definitely not running on the same platform. And so this idea that you can have agents work as teams, or more importantly, even if they aren't the same team, send tasks back and forth between either agents or collections of agents in a secure, trustworthy, predictable way. If you open up agent to agent, really that's what's going on inside of it. More recently, we added the ability to add tokenized e-commerce, so you can not only do the task, but you can exchange basically financial information across that link, and very similar to how tokenized financial stuff works in things like Apple Pay and other vehicles. But the bottom line is it's really meant to be an interworking protocol between either two agents or two sets of agents or two agentic systems that allow them to exchange tasks and pass work back and forth between each other in a reliable, secure, predictable way. There are a number of underlying technologies that came with it. For instance, this concept of agent cards, where we want to basically know how to find what the agent at the other end can do and what its capabilities are. We are working through ways to do agent identity to make sure that they have a secure way to know the agent at the other end is actually trustworthy. But the bottom line is A2A is primarily there just to let one or more agents on each side of a link exchange information between each other for the purpose of getting work done, tasks, and to some extent be able to bill for those tasks or commercialize those tasks. MCP is a very different protocol. MCP was built by the model makers that basically wanted to access external data sources and interact with the real world. And so MCP largely sits as an interface to allow an agent to, through a standardized interface, access external data sources and use external tools. So it's kind of bidirectional. It allows them to, through MCP, you can connect to any number of different systems that express themselves via MCP as data sources. And we've seen this in a number of areas where people are presenting MCP on top of cloud-based services and web services. Sometimes that's quite complex and surprising because it isn't a really well-controlled protocol. But the bottom line is, think of MCP as a nice normalization layer that if you have data sets and data sources and you want agents to be able to use them, however those agents are defined, whether they're a software system or a feature of a model, they have a protocol now that can make that quite easy to do and generally quite open. The second piece, though, is the ability for the agent to actually interact with tools, because the way we interact with tools, our tools tend to be quite diverse. They have different interfaces and APIs. MCP kind of normalizes that layer. And so an agent can not only get information, but if it decides it wants to take an action, it now has a kind of normalized interface to do that. Now, there's still gaps in MCP, but largely it is pretty well defined for that job. We have some concerns with it because the security architecture on it is very open. It's designed to kind of just ingest lots of data and access tools as if they are freely available, which is really what's going on in the consumer side out in the cloud. But when you're applying this to an enterprise, you want a whole lot more controls. And so from our purposes, while we think this is a very powerful tool, we've made an early decision that all of our MCP services in the company will actually be centralized and contained within effectively a DMZ, where we can put robust controls around the MCP environment. We don't allow MCP in the wild in Dell, but we allow MCP to be a curated service that we attach to agentic platforms so that they have an easy open interface for data access and for tool use, but we have rules around exactly what they can do, which tools they can access, and where they can go. We think that's a good mitigation of the early security issues. We expect MCP and A2A to continue to become more secure, more have a greater ability to do authorization, not just authentication. And over time, we will see, these protocols need less outside security capabilities than what they have today. But the bottom line is these two protocols, at least our point of view, is they are complementary. You have agents that need to talk to each other, and that's great for A2A. So systems can cross domains and share work. And then you have agentic systems that need to interact with the external data sets and the tools of the world. MCP gives us a nice vehicle to do that. Okay. Now, I described it that way. I would encourage you to go talk to 10 people about MCP and A2A. Some of them will be quite religious about which ones they prefer, and the other one's a terrible idea, and everybody was trying to establish one protocol to rule them all. I am a longtime networking guy. You don't run the internet with a single protocol. There are lots of things that have to happen, and it's not surprising at all that we have at least two protocols that are emerging that are important around the agentic systems to make them work. Now, as we start to think about long-term where this goes, one of the confusing points is that there are features in A2A that the MCP world might want to do. It's not unrealistic to think that an MCP server might have an interworking interface on it at some point. It's also not at all surprising to think that an A2A interface might talk to a system that's really expressing tool use. And so we have to watch carefully, because while these protocols exist independently today, there is a gray area between them that will become more gray. And that's going to be an industry discussion about, do we really want one protocol? These are very different architectures. A2A is more of a distributed networking architecture. MCP is more of an embedded secure system architecture inside the compute world. And if we're trying to solve interworking, that's a networking problem. If we're trying to solve tool use, that is a feature of the actual compute world. And so you got to be careful about merging these two. Our biggest concern is that they get merged in a way that isn't done well, or they try to step too far into each other's domains, and you end up with a system that's highly centralized that has to create the equivalent of a distributed system, or a distributed system that has to behave like a centralized system. We know those are not the same thing, and they never work out well when you try to apply a distributed architecture to a centralized problem, or a centralized architecture to a distributed problem. We have both sets of problems in the agentic world, and we'll continue to have them. So a lot of my researchers and advanced technology folks are watching this space, because in current course and speed, we're going to see some collisions between these two protocols. We're going to try to keep them separate as much as possible, at least in their swim lanes, because the problems they're solving are worth solving. The good news story is both of them have ended up in the Linux Foundation. They're not in the same part of that organization, but over time, we know that getting these things into a structure where you have an open source ecosystem where people can engage, and because it's part of LF, we can talk about how they work together. We probably have the right framework. It's just up to us to not make this a battle about one must win. I'm a big fan of having, like I said, more than one protocol to run the internet. There's probably more than one protocol that's going to be necessary to run agents. And if we end up with MCP and A2A and maybe even a third doing some piece that we haven't even expected, that's perfectly manageable. But what we don't want is chaos of these things collapsing into each other and having wars about which one's going to win. So keep your eye on that. Stay focused on what really matters. Every agentic system you build will have far more value if it can connect and talk to other agents. And every agentic system that you build will be far easier to implement if it has standardized interfaces for data access and tool use. The trick is to make it secure, to make it interoperable, and to make it functional. I think we can do that with what we have. And inside of Dell, that's exactly what we have chosen to implement. A2A is our default interworking protocol. MCP is our default tool use and data access protocol. But we trust neither of them, so we wrap security around them today to make them enterprise grade. And at that point, we feel like we can go into production. So again, hopefully that's useful to you. We'll share more as we're learning more, but the bottom line is you're going to have a system called Agentic, And that system's going to be dependent on not just the existing protocols you understand, but new protocols. You'll have to learn them. But more importantly, we're going to have to realize this is a system, and it's going to require us to be able to walk and chew gum at the same time, meaning we're going to have more than one protocol to do all the things necessary to make an agent be an agent and do its work successfully. So hopefully that's useful. We'll talk to you all soon.